to be talking about classifying polygons. It's a real short lesson discussing a few characteristics of polygons, classifying them, and a couple of vocabulary words that go along with polygons. So the first one is we have to know the 3 characteristics of a polygon. The first one is that the shape must consist of straight line segments only, no curves. The second characteristic is that the shape must have only one interior region. And the third characteristic is the shape must be a closed figure. So if we look at this polygon over here, this is a polygon. It has all 3 characteristics that we're talking about. Now I have a few examples of things that are not polygons. If we see this first one, this circle, it's not a polygon because we have a curved line. The second one, it has 2 interior regions, so that cannot be a polygon. And the very last one is an open figure and it has a curved line, so that cannot be a polygon. So what I'm going to do is in my next slide, I have a couple examples of different shapes and I'm going to tell you if they are polygons or not. So the very first one, it is a polygon. It has all straight lines, one interior region, and it is closed. So it is a polygon. The next one is not a polygon because it is an open figure. The one next to that is not a polygon because we have a curved line here. All right, let's go to the second row. This next one is not a polygon because it is an open figure. This next one, this should look like this. This next one is not a polygon because it has a curved line. Okay, and then the one after that is a triangle, and this is a polygon, and it is a polygon because we have straight lines, one interior region, and then no open areas. Okay, let's look at the third row. This next one is a polygon because we have straight lines, one interior region, and it is not open. All right, this next one is not a polygon. First of all, because it has curved lines, and it has 2 interior regions. So that's 2 reasons why it's not a polygon. And this very last one is not a polygon because we have 2 interior regions. Okay, so that's how we can determine if something is a polygon or not, by following those 3 characteristics. Now we have 2 different types of polygons. We have a convex and a concave polygon. And there is a line test that we can do to determine if it's convex or concave. So what we're going to do is we're going to trace over the side, but we're going to extend it out. We're going to do that for all sides. Okay, and if we extend out all sides, we notice that the red line never goes through or inside the polygon. If that happens, it is a convex polygon. A concave, let's do the same thing. Let's trace these sides. Okay, let's try this one. Wait a second. If we see that line, if we extend out that side, it goes through or inside the polygon, so that is concave. And it looks like kind of the sides are caved in. So it's 2 different ways. If the line goes through the polygon, it's concave, or if the sides look caved in. So that's your convex and concave. So let's look at 2 examples. Let's take these 2 polygons, use the line test. So I'm going to trace over all of these sides and extend them out. And since none of these red lines go through the polygon, this is convex. Let's do the other one. And we have to trace through every single one. Oops. I went off the line there. Let's do that again. Oh, and if you look at that, if we extend out that one side, it goes through the polygon, so it is a concave. And if you look, these sides kind of look like they're caved in as well. So it's 2 ways to determine that. Okay, now I have 3 more vocabulary words for you. Okay, the first one is equilateral, and that means that all sides are congruent. Equa meaning equal, and lateral meaning a line or a side. That's the way I remember that. And if you look at the picture, that's an equilateral triangle. And remember, those red dashes mean that things are congruent. So we even can look at the picture and it tells us that all sides are congruent. So we have to be able to identify those symbols. The next one is equiangular. That's when all angles are congruent. If we look at this rectangle, all the angles are 90 degrees, so they're all equal, so they're all congruent. Equa meaning equal, and angular meaning angles. So that is equiangular, if all the angles are congruent. And the very last one is a very special type of polygon, and that's if all sides and all angles are congruent, just like the square over here. All the sides and all the angles are congruent in a square, and we call that a regular polygon.